Okay, so welcome to the quality lab. So this is our quality, and after our calls are made in the field, then in the warehouse in the back after yield and test weight, the next thing that they do is we have to figure out the whole protein content of our seed. So this machine is called the NIR machine, near infrared spectroscopy. So yes. So this machine isn't turned on, but the basics is that it shines a beam of light, and there's actually, right here, there's a piece of glass, and the beam comes through. We have a cup that has a glass bottom, and we just put in a sample of seed like this, make sure it covers the glass nicely. We put a plunger on, as you can see, all the glass is covered. Just put it in, you just press a button, 30 seconds, it'll spit out a number for you. So if it's 11% or less whole protein, that is considered a low protein wheat. 12% or higher, we consider that a high protein wheat. So then after this quality test, culls are made again. And after that, we do the sedimentation test, which gives us our gluten strength test. And that'll be right here on the other side.
Great, whenever you're ready.
All right. Okay, so the sedimentation test. So we call this the SDS test, which is short for sodium dodecyl sulfate. And this is because, as you can see, so we put whole meal flour into this, which means that we put the whole seed in and we grind it. And it is 2.5 grams of meal into a test tube. Then 25 mils of distilled water is added, vortexed, and we wait 15 minutes. After that, we add 25 millimeters of this working solution, and the working solution is the sodium dodecyl sulfate with lactic acid and water. After that is added, we invert it a few times, 20-minute wait, and then we measure actually how far our meal has fallen. So as you can see, this is a hard red wheat. This is a soft white. And you can actually tell because obviously this one, when is measured in millimeters, will be about over 70, while this one just measures under 30. So what does that mean? Okay. So the whole purpose of this test is gluten strength. So gluten is made up of 2 proteins. So gluten is actually gliadin and glutenin. And you don't actually get the formation of gluten until you add water. Obviously, that's why we add this, the water. So what happens is, if it's a hard red wheat, we know it should have a higher gluten content, so it'll have a higher gluten strength. There we go. If it is a soft white, or like a pastry flour or a general purpose one, then it will have very little gluten, like this. So obviously, the rate of sediment settling is going to be correlated to the gluten strength that the wheat has. So this is why we do this test. So the sodium dodecyl sulfate actually will break everything up, and because it takes longer to get through the complex proteins of the hard reds, it will take longer to settle down, which also means this is time sensitive. So if I actually left these overnight and came back, this one would be just as small as this one. So it is all time sensitivity and how long it takes for that chemical to break down the gluten. So that is the sodium dodecyl sulfate test. So falling number is our next test, and falling number refers to how fast this rod will fall from the top of this tube all the way to the bottom. So that is falling number. Falling number is measured in seconds. So we have to grind the wheat meal. We just make it into a meal. So I have one sample here, another one. This is 7 grams. So we have to add 25 mils of distilled water. Have to shake it very well, and I have tried with my hands, and it does not do anything that this machine does. that's it. Okay, so when it's shaken up really well, then we just put these rods in. Whoop. There we go. All right, and it's ready to go in. So this is the machine that does our falling number. This whole tank right here is filled with boiling hot water. So we put the test tubes in, we close it up, and the machine will do its thing. It will stir this up for about 60 seconds just to get it all uniform. And then after 60 seconds, it will actually take the sticks and just release them from the top. So this is literally all gravity. So the whole point of this is to test for pre-harvest sprouting. Now, when grain stands in the field, and for example, you can't get to harvest or something, the problem is obviously is that mature grain will start absorbing water. Now, depending how much it absorbs, it can actually start sprouting inside the grain. So if too much water gets through that bran barrier, what ends up happening is it actually stimulates the production of an enzyme called alpha amylase. So alpha amylase will start degrading the starch inside the seed, and this is actually to provide the glucose necessary for the baby seedling to grow, for the germ. So yeah, so the whole point of this test then is if that stick falls really quickly through that, that means you have more simple sugars inside. It means there's actually more alpha amylase. So the lower the number, the higher the sprouting damage. So it's a negative correlation. So the higher the number obviously means that the stick falls slower, which means that there's still more starch in there and it's thicker. So therefore there's less sprouting damage. So that is the point of the test. So right now the sticks are falling. And yeah, in about a few minutes, we'll see how the results will come out. Now, usually I feel the best ones are about between 300 to 450 seconds. So about there. Yeah, so we can come back when that is finished and we can see what it looks like. Okay, so our last quality test, this is called the Mixograph test. So this is the Mixograph machine. As you can see, there are pins on here. This machine actually will calculate how long it takes to develop dough. So 10 grams of properly milled flour go in here. So properly milled means that we actually have to go into our grain. We have to test the moisture that it's at. It's pretty dry here in Edmonton, so ours is about 4 to 7% if we're lucky. So we have to actually raise it to 14.5%. And then when it's milled, we kind of assume that we lose 0.5% moisture. So our goal is to have it at 14% moisture. That is the standard, I guess, for testing it. So yeah, so once that has been done and it's been properly tempered, which means it's been properly brought to moisture, then we mill it. And 10 grams into this bowl, 6 milliliters of water. This water is usually at 55 degrees Celsius, so it has to be warm water. So we put it into this bowl, and once that is all in, there's also a water bath that goes through, so there's warm water circulating around this bowl as well. So what happens is that you just put in the bowl, snap this into place, then do this, and it automatically starts mixing. So once this is pushed down, what happens is there's a program on this computer, and it will actually measure the amount of energy it takes to get to the dough stage, and also how long it takes for it to be properly developed into a dough. So this is obviously important because if you want to have a bread making wheat, you probably want to know how your dough development time will be. This nice graph right here is really good because of the short development of dough between just over 2 minutes. and the gradual slope, which means that there's forgiveness. That means you can keep mixing and you still have that chance to make it a good dough, right? So if there was a very sharp decline right there, then that would be culled immediately. So yeah, so that's an example of a good graph of mixing development. Another one, this is also considered quite good, and I believe this is actually a check. So yes, so these are the curves we like to see. We don't want to see anything sharp, anything angular. So yeah, so this is the Mixograph test. Yeah. All right, so our falling number machine is done. So we have this one at 378 seconds and this one at 244. As you can see, there's boiling over happening, which means that the one at 244 is so watery that it's literally boiling over. So I can show you right here. All right, 244 seconds, 378. So this does not pass. As you can see, if I pull this up, it is so easy to just take it out of there. But look at this. Whoa. You know, it's got some give there. So obviously we have pre-harvest sprouting right here, and this one seems to be sound. So yeah, so that's how you can tell if your wheat's okay or not. So that's the falling number test.